Welcome to Kenton's videos. Enjoy the video.
You begin by confirming prerequisites and taking a baseline. Check framework and driver versions, CUDA, cuDNN, and the model runtime, because mismatches break optimizations. Once done, enable the network boost flag in your config and free enough GPU memory so the scheduler can allocate buffers. Make a small test run to collect throughput, latency, GPU utilization, and network bandwidth. These metrics let you compare before and after, so you know whether fixes actually improve performance. You now perform the detailed tuning that actually restores boost. Increase batch size cautiously and raise prefetch and data loader workers to keep GPUs busy. If you overshoot, latency spikes. Then tune interconnects. Adjust NCCL settings, socket buffer sizes, and TCP window scaling to sustain throughput across nodes. Once configured, enable asynchronous transfers so compute and communications overlap. Profile another run with traces and timeline views to see where stalls remain. You finish by validating at scale and locking the working configuration into your deployment. Run a multi-node validation, compare throughput and latency against baseline, and save the exact flags, versions, and tuned values. Then add health checks and rollback triggers for sudden network or memory regressions. If the boost still fails, isolate the fault. Test NIC and driver independently, swap cables, and run a binary search of code changes. This pinpoints whether hardware, driver, or model code caused the issue.
Thanks for watching. Consider subscribing if we helped you.